Okay, I need to be fast. I need to go to jog with my dog. So let's end this, the last 5 questions. Which of the following property of wave is false? This one you actually can refer to your textbook. But anyway, let's do it. Frequency is the number of complete wave made by each second. This is correct. That's the correct definition of frequency. Just to ask you, what is the SI unit of frequency? What is the unit of frequency? If you are guessing, refer to the textbook now. Okay, B. 1 period is the time taken to generate 1 complete wave. This is also the correct definition. Ask yourself, what is the formula to change period to frequency? Second question to ask yourself, what is the unit, SI unit for period? If you don't know, you're guessing, look at your textbook. Let's look at D first. Amplitude of the wave is the maximum displacement from rest position. Remember, whenever you are talking about amplitude, something about distance or displacement, you must tell me where are you measuring from. So in this case, rest position, correct. Same question, amplitude, what is the SI unit? How to identify amplitude from a graph? Go and look if you are guessing. Okay, compression and refraction are the region of different pressure transverse in a transverse wave. It looks correct. Yes, compression and refraction are of different pressure, because compression you are pressing things together, refraction you are stretching things to outside, so of course the pressure will be different. But is it transverse wave? No, this is not for transverse wave. It is for longitudinal wave, like sound. Okay, do you know how to spell longitudinal? Go and look at your book if you don't know. Question 17, like I said, there will always be one question on wavefront. What you are seeing here are wavefronts. Wavefronts are imaginary line joining the peaks of a wave, meaning that every wavefront, it is a point of the crust. So if you imagine that this is a wave, it looks like that. Okay, every line represents a peak. So how do you calculate this? Let's do it together. You want to find the period. So you want to find the period T. In order to find the period, you need to know F. If you need to know the F, you can't tell it from here, right? Because it only tells you 15 cm and 5 seconds. Okay, you can't really tell anything. So what to do? You have to rely on 2 different formulas. First formula, don't look at this first. It's a very simple formula. V speed is equals to distance over time. So you know that the wave has traveled 15 cm and the time taken for it to travel 15 cm is 5 seconds. So using that, you can work out the speed of the wave. Now be very careful, because what you are finding is 15 cm. So your unit here will be 3 cm per second. Change it to SI unit. Cm is 0.01 meter. Change it. Then use the wave speed formula. The speed depth of the wave will be the same as this speed. Frequency is the one that will enable you to find the period, but you do not know now what is the frequency. So you know the speed. Do you know the wavelength? Wavelength they didn't tell you directly, but they tell you that this amount of wavefront is 15 cm. So how many waves are there? This is 1 complete wave, 2 complete wave, 3, 4, 5. So 15 cm, 5 complete wave. So 1 complete wave will be 15 divided by 5. So 15 divided by 5, you will get 3 cm. So let me do this slowly. 1, 2, 3, 4, 5. So your number is 15 divided by 5 cm. So it is 3 cm. But I need to convert it to SI unit, meter, 0.03. That's how I get the 0.03 here. Okay? So this speed, take from here. This number, get from the diagram. You work it out. F is just 1. F is equals to 1 over T. So this one, if you do your mathematics correctly, it will become like that. Okay, so do the same thing, you will get T equals to 1. Can? Yeah? So that's why your answer is A. Okay, question 18. Question 18, it is your spring key. Okay, which distance represent wavelength? Look at this. This is a compression, right? It compresses. This is a compression. This is a compression. Look at the textbook. Definition of wavelength is either the distance between two peaks, the distance between two draft, if not the distance between two compression, right? So distance between two compression is P to R, if not R to T. So P to R, A. Okay, this is your definition. You need to read on it. Okay, last two questions before I go for my job. Okay, question 19. Vibrator of frequency 5 Hz produce a water blah 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 blah. And you got this thing. So basically you want to find frequency and they give you wavelength and speed. So the only equation that relates speed, wavelength and frequency together is your V equals to F lambda. Okay, so what you need to do is that you need to substitute the value into it. So for example, I will do one for you. If you have a speed of 2.5, right, then you have F, okay, 5 Hertz, we know it's 5 Hertz, right? Wavelength is 2. 2 times 5 is 10. Will it give you 2.5 speed? No, right? So you know that this option is wrong. So do it again. 2 for your B. Okay, your frequency is 5. Your wavelength is 2. Does it give 10? 2 times 5. Oh, 10. 10. Oh, okay. All check out. So it's B. Okay, if you don't believe me, try the rest. Okay, which of the following is not a property of EMA? EM wave is your Gorilla X unit randomly in my room. Okay, they are all transverse wave. Correct, they are all transverse wave. They can travel through vacuum. Yes, because they are all transverse wave. They have the same wavelength in vacuum. Ta-da! Okay, the wavelength and the frequency will change. Why? For example, gamma wave. Gamma wave is a high frequency wave, meaning that it will have short wavelength. Radio wave is low frequency wavelength. It means that it will have long wavelength. So EM wave, they will have high frequency, low frequency, short wavelength, long wavelength. So they are all different ones. They transfer energy from one place to another. Yes, that is what wave does. Okay, they transfer energy. Okay.